need to execute server-side functions, and handle their results with just a few lines of clean, Async Python. You'll see how the FastMCP client lets you list available tools, call them with arguments, and process the results, all while managing the connection lifecycle automatically. The pattern is simple: connect, execute, and get structured data back. Async with client. Hash list available tools. Tools equals await client list tools. Hash execute a tool. Result equals await client, call tool multiply. 5b, 3. Print, result data hash 15. This demonstrates the context manager pattern combined with a declarative client API for protocol interactions. The design encapsulates connection lifecycle management within an async context block, while exposing server capabilities through simple method calls. What makes this distinctive is how it separates transport concerns from protocol operations, letting you focus on what you want to do rather than how to connect. The pattern works by establishing a clean boundary between connection management and business logic. The context manager handles all setup and teardown automatically, while the client methods provide a type-safe interface to server capabilities. This separation means you can switch transports or servers without changing your operational code, and the framework manages retries, timeouts, and protocol details behind the scenes. This approach matters because it eliminates the boilerplate typically required for RPC interactions. Instead of manually managing connections, serializing requests, or handling transport-specific quirks, you work with a consistent interface regardless of whether you're talking to an in-memory server, HTTP endpoint, or subprocess. It's particularly valuable for testing, where you can swap real servers with mock implementations without modifying test code, and for building higher-level systems that need reliable, deterministic server interactions. Let's break it down line by line. Async with client. This uses Python's Async context manager pattern. The Async with block ensures proper connection handling, automatically opening the client at entry and guaranteeing cleanup on exit, even if an error occurs. Critical for resource management in Async code. Hash list available tools. Tools equals await client list tools. This fetches the list of available AI callable tools from the server. Required first step to discover what operations the connected MCP instance supports before making calls. Hash execute a tool. Result equals await client, call tool multiply. 5b, 3. This executes the multiply tool remotely with arguments passed as a dictionary. The await handles the async RPC call, returning a structured result object that includes the computed value in its data field. This demonstrates the core pattern for invoking any registered tool by name with its required parameters. Print result data hash 15. This outputs the tool's return value from the data field. The result is a dictionary with structured output, where data contains the actual computation result, here, the product of 5 and 3. This pattern keeps raw results separate from metadata like status codes or timestamps. FastMCP client execution pattern. The call tool method bridges Python execution and AI workflows, handling everything from simple arithmetic to complex progress tracking operations through a single interface. Timeout values override client defaults, but don't interrupt server-side execution. Only the clients wait. Always validate tool names and argument schemas before calling to avoid runtime surprises.
The client that never waits still receives everything.